You're welcome to Maths, and I got a new video on this video series, and we have discussed this in our previous video. So now let's move to the part 5. And in this video we will going to explore more speciality of the extreme and mean ratio. So the first one is Fibonacci sequence. It is a sequence starting from 0, then 1, and then the next term will be the sum of the two consecutive preceding terms. Then like that it will increase. 2 plus 3 is 5, then 5 and plus 3 is 8, and then 8 plus 5 is 13, and so on. And when you take the ratio of the term to its preceding term, and like that when you move ahead by taking these ratios, you will be shocked that it will be approaching the extreme and mean ratio, and again a golden ratio, because now extreme and mean ratio is in the phase of moving towards the golden ratio. And this is the first speciality of the extreme and mean ratio, that it is connected with the Fibonacci sequence. Now like that there are many speciality by which extreme and mean ratio becomes golden ratio. So let us assume that extreme and mean ratio became the golden ratio, because we have to define some terms related to golden ratio, even though there are many misconceptions related to it, but we will discuss it later on the video. Now from the second term of the Fibonacci sequence we can construct a 1 unit length square, and from the third term we can again construct a 1 unit length square, and from the fourth term we can construct a 2 unit length square like this, and from the fourth term we can construct a 3 unit square like this. As you can see, this is the add up become 3, so this can be drawn like this, okay. And from this unit is 5, so you can construct a 5 unit length square, or here you can create 5 unit length square above as well. So remove this, and now you can create a spiral like this, as you can see. Now this length is totally 8, so you can create 8 unit square length like this, and this spiral is going to be here, okay, from here, okay, this point, this is not, okay, this point like this spiral will go and go again and again, and this spiral is named as golden spiral. And these all square collectively known as, all the squares that are here collectively known as golden square, okay. This is a set of the square, okay, because golden spiral can give you a sense of Fibonacci sequence, but in a single square there is no any kind of extreme and mean ratio, so you can't call a single square as golden square. Similarly, the set of these all golden circles that is present inside the square are called collectively golden circle, because in a single circle there is no any kind of extreme and mean ratio present. Leaves on a stem, seeds in a sunflower, human beauty, nautical shell isn't necessarily always exhibit pattern that approaches phi, the golden ratio or extreme mean ratio. And even the work of the Leonardo da Vinci told to be based on phi, that is the Mona Lisa work, but think it's a real person and not an idealized image, and therefore these claims are baseless. But even though, why extreme and mean ratio is so much popular to be called as golden ratio? And the reason is due to its speciality, the real speciality. And we have discussed the real one speciality, the two speciality till now. One is the extreme and mean ratio for constructing the regular pentagon, and the second one is the connection of the golden ratio or extreme and mean ratio with the Fibonacci sequence. And such type of speciality we will discuss more in our upcoming videos on this series of the golden ratio. Now to connect all the history and try to find out why the extreme and mean ratio will become a golden ratio, and that will be done in our upcoming video of this video series. Hopefully you get it, so don't forget to like and subscribe.